between the wheels and the track. The solution is to take both these factors out of the equation. It sounds like science fiction, but trains that do just that really exist, and they're called maglev, which stands for
magnetically levitating trains. There are no overhead power cables because the power source is built into the track. There's no friction from the wheels because, well, there aren't any wheels. The train is designed to float 10 millimeters above the track, so the only resistance it has is air resistance, which makes this train fast. Very fast.
Here at the Transrapid test track in northern Germany, they're testing a technology that they hope has the potential to take over where the TGV meets its limits, with enough speed, not just for intercity, but for intercontinental travel. But like so many record-breaking trains of the past, not one, but two rival operations have been battling it out to turn this technology into the world's fastest passenger service. The German Transrapid system and the Japanese JR Maglev.
Maglev trains are all about magnets, and magnets have two poles, north and south. And when the facing poles of each magnet are the same, like in this instance north, north, they repel. Like so. The Japanese JR Maglev system uses this force to lift their trains.
Magnets on the train face magnets with similar poles on the track, and the train rests on the repulsive force as if it's sitting on an invisible cushion.
Like so.
Japanese maglev trains have reached speeds in excess of 580 kilometers an hour using this system. But the technology is still confined to the test track. They've never managed to turn it into a commercially viable passenger train. While the Japanese system uses the repulsive force of magnets, the German system makes use of attraction.
But it's no use having the train sticking to the tracks. The trick to hovering is to use electromagnets. Now, an electromagnet is just a piece of metal with wire coiled round it, like so. And when you put some current through that wire, like this, it's attracted like so. When you switch that current off, it drops. Attract, drop, and so on.
And if you were to switch your electromagnet on and off fast enough, like this device does automatically, you can defeat gravity, attracting and dropping so quickly that metal objects like my toy train here appear to hover.
Incredible. I don't know about you, but I think that's pretty damn amazing. And that's magic. The Transrapid has massive electromagnets in here that sit under the track. And when the power is switched on, power on, bitte. The magnets are attracted to the track, and now the train, the whole train, is floating in midair 10 millimeters above the track with magnets at the side here to keep it steady.
A completely separate system of magnets built into the test track create a moving magnetic field that pushes the train along with it, just like a surfer riding an invisible magnetic wave. And this makes the system very efficient, because you only need to switch on the bit of track that the train is running over.
Now that click means that this section of track has just been electrified or energized, and that means the train is just about to go past.
And it's just as impressive from inside the train.
We're now approaching the fastest part of the track. Let's go and take a look and see what speed we're actually doing. If I go up here and just check the driver's screen, and we're doing over 300 kilometers per hour. We're still increasing speed now. It's probably about 325, 330.
That's already faster than the TGV, and we're still picking up speed.
Very exciting, it really is. If we look out the front, we can see that we really are moving. The sensation of speed is phenomenal. Look at that. We're now approaching the top speed, 390, 400. We are at 400 kilometers an hour.
At that speed you could go right across Europe from Paris to Moscow in just 6 hours. On October the 11th, 2003, the Germans got one up on the Japanese when a 30-kilometer track between the city of Shanghai and its airport opened its doors to the public. Using the German Transrapid technology, this billion-euro project became the world's fastest passenger train, regularly topping 430 kilometers an hour. This is a fantastic piece of kit, but countries aren't exactly queuing up to take on this technology. The problem might have something to do with the cost, somewhere in the region of 50 million euros per mile to create a maglev system. Unlike City of Truro and the TGV, it seems that for maglev, simply being the fastest isn't going to be enough. Maglev is going to have to get an awful lot faster. And in theory, at least, that's already possible. By building vacuum tubes for maglev trains to run in, speeds in excess of 3,500 kilometers an hour would be possible, making the trip from London to Tokyo a jaw-dropping 3.5 hours. Now that really would be massive speed.